Okay, so we've got the integral of 1 over x to the 4 times the square root of 9 minus x squared dx. Okay, this integral is going to involve trig substitution. So we have the square root on the bottom that can be rewritten in the form of a squared minus x squared. Our a squared term is going to be 3 squared minus x squared, like that. So this is our a and this is our x. We know that when we have that form, x equals a sine theta. Now we know that our a term is 3, so that can be rewritten as x equals 3 sine theta. Now we want to take the derivative of both sides, which gets us dx equals 3 cosine theta. And now we can take that and plug in our x, which is 3 sine theta for x here and here. And then our dx is going to be 3 cosine theta d theta. All right, so let's rewrite our original integral. So we have the integral. There's going to be a lot written here, so make that big. So we've got 3 sine theta to the 4th power times the square root of 9 minus, we'll put this in parentheses, 3 sine theta squared. And that is 3 cosine theta d theta. Okay, so our 3 sine theta to the 4th power is going to become 81 sine to the 4th theta. And then inside of the radical sign, we've got 9 minus, well, 3 squared is 9, sine squared theta, which that equals, we can pull the 9s out, and then that's 1 minus sine square theta, which is the same as writing the square root of 9 times, well, our identity says that this is equal to this cosine squared theta, and the square root of 9 cosine squared theta is just 3 cosine theta. So this will go in for this, and this will go in for there. So we can rewrite this as the integral 1 over 81 sine to the 4th theta times 3 cosine theta, and then we still have our 3 cosine theta d theta. All right, now with that out of the way, we see that this cancels out and this cancels out. And then we can pull our 1 over 81 out to the front of the integral. So that gives us 1 over 81 times the integral of 1 over sine to the 4th theta d theta. Now, when we look at the 1 over sine to the 4th theta, we know that 1 over sine theta is the same as cosecant theta. So we can rewrite this integral as 1 over 81 times the integral of cosecant theta. Cosecant, well, we can't forget to the 4th, theta, d theta. Now at this point, we can't take the integral of cosecant to the 4th theta. So what we're going to have to do is we're going to have to introduce a power reducing formula. So for the cosecant to the nth power theta d theta. That is now going to equal negative cosecant n minus 2 theta times cotangent theta, all of that over n minus 1 plus n minus 2 over n minus 1 times the integral of cosecant n minus 2 theta d theta. Okay, we're going to use that now to replace cosecant to the 4th theta. So what I'm going to do is, instead of clogging this part of the whiteboard, I'm just going to move to the next section of my whiteboard. Okay, so we now have equals 1 over 81. I'm going to put this inside of brackets. We've got negative cosecant, well, our n is 4, so 4 minus 2 is 2, theta, times cotangent theta. That is going to be over n minus 1. Our n is 4, so that's going to be over 3. Plus n minus 2 is 2, n minus 1 is 3, times the integral of cosecant n minus 2 is squared theta d theta. Now what we have to do is just take the integral of cosecant squared. So we'll rewrite all this. 1 over 81 negative cosecant squared theta times cotangent theta over 3 plus 2 over 3 times, well, the integral of cosecant squared is negative cotangent. So we got negative cotangent theta like that. Okay, so now where do we get cosecant and cotangent from? Well, this is where we look at our right triangle. So I'm just going to draw a right triangle over here. This is theta. We use sine, so we know that opposite is x. Hypotenuse is 3. That means this edge right here is 9 minus x squared. So cosecant theta equals, well, cosecant is the inverse of sine. So sine would be x over 3, so cosecant will be 3 over x. And the only other one we got to figure out in here is cotangent. So cotangent theta, well, the inverse of tangent is cotangent. Tangent would be opposite over adjacent, which would be x over the square root of 9 minus x squared. So cotangent is going to be the square root of 9 minus x squared over x. Now we just plug in this and this in over here. So we've got 1 over 81 negative sign. So we've got cosecant squared. Cosecant is 3 over x. And that's squared. Times cotangent. Cotangent, we found over here, was the square root of 9 minus x squared over x. And all of that is over 3. Plus 2 over 3 times negative cotangent theta, which is the square root of 9 minus x squared over x. Okay, now we can just simplify this up a bit. We've got 1 over 81. That becomes negative 9 over x squared times square root of 9 minus x squared over x, all of that over 3. And I'm going to distribute this negative sign, so we got minus 2 over 3 times the square root of 9 minus x squared over x. Now if we clean up this side right here, we end up with 1 over 81. We got negative 3 square roots of 9 minus x squared over x to the third minus, and cleaning this up right here, we end up with 2 square roots of 9 minus x squared over 3x. Now we get like bases here, and we can have it equal 1 over 81 bracket. We've got negative 9 square roots of 9 minus x squared over 3x to the third, top minus 2x squared, square roots of 9 minus x squared. And then, finally, we can distribute our 1 over 81 back into here to get our final answer, which is going to be negative 9 square root 9 minus x squared minus 2x squared square roots 9 minus x squared, all of that over 243x cubed plus c, and that is the final answer to this integral involving trigonometric substitution. Thanks a lot for watching, hope you enjoyed, and I will see you next time.